Okay, so what we're going to look at now is we're going to start factoring. We're going to start looking at some other techniques of factoring here. We're going to look at two more techniques. We're going to factor by grouping, and then we're going to do some factoring quadratics here. So, factor by grouping is a pretty useful technique in several ways that we're going to look at. So, if a polynomial has 4 terms in it, so if we have a 4-term polynomial, we can try to factor it by grouping. So, how do we use grouping? Like, what do we do? Well, the idea behind this method is to group the first 2 and last 2 terms together, and then factor the GCF from each group separately. So, if I look at these, alright, all 3 of these polynomials that we have here, they all contain 4 terms. So, if a polynomial has 4 terms, you should consider using grouping. So, since we have a 4-term polynomial here, we're going to consider factor by grouping. Now, if you go through this, you'll see that, alright, there is no GCF for the whole thing. 3, 18, 2, and 12, they don't have a GCF. And they don't all have x in common. This is just a number 12. So there is no GCF in the whole thing. However, what we could do is we could group the first 2 terms and the second 2 terms separately. And what we could do is we could factor a GCF out of the first group and second group separately. So if I just look at each individual group, so what's the GCF in 3x cubed and minus 18x squared? So what's the GCF between 3 and 18? Well, it's going to be 3. And what they have in x cubed, x squared, the highest they have in common there is x squared. So the first group has a GCF of 3x squared. Now what about the second group? So now 2 and 12, they have a common factor of 2. Now they don't have an x in common, so there is no x here to tack on. So the GCF here is 2. Now, is it 2 or is it negative 2? Now, since we're looking at the second group here, we're considering that group separately. So remember, when we saw in the previous section, if your leading coefficient is negative, you got to factor out that negative along with it. So I have negative 2x plus 12, not just positive 2x plus 12. So because there's a negative here, I'm going to factor that negative along with this GCF. So my GCF isn't 2, it's negative 2 in the second group. Alright? It's negative because I have a negative here in this second group. So now that I know my GCFs for each group, I'm going to factor that out of each group separately. So I'm going to factor a 3x squared out of the first group, and I'm going to factor a negative 2 out of the second group. So when I factor 3x squared out of 3x cubed, I have an x left over, right? And then when I factor a 3 out of negative 18, well, 3 out of negative 18 is what? Negative 6, right? And x squared times 1 gives me x squared. So when I factor 3x squared out of the first group, I have x minus 6 left over. Alright, now I factor a negative 2 out of negative 2x, I have a positive x. And a negative 2 out of positive 12, well, a negative times what gives me a positive? Another negative. 2 times what is 12? Negative 6. Okay, so this is what I have now. Now I want you to look here. Now if I look at the whole polynomial, so this is this times this quantity minus 2 times this quantity. So if I look at this whole thing again, if I consider this whole thing again, well, guess what? Now what I want to do is I want to factor the group. Or I want to factor the common GCF again. Now this whole thing has a common GCF. And the GCF it has is not just one term, but a binomial itself. So if I look at this first group here, right? If I look at this first group, 3x squared times x minus 6, I have an x minus 6 in common. And if I look at the second group, I also have an x minus 6 in common. So this first group and second group have an x minus 6 in common. So the GCF here isn't just a term, it's a binomial, and it's the binomial x minus 6. So the binomial here isn't just a single term, it's a two-term polynomial, it's a binomial. So now I can factor this out of the whole thing. So when I do that, so when I factor x minus 6, when I factor that out of here, right, just the first group, right, when I factor that out of there, what do I have left over? In other words, what's missing? The 3x squared. Again, this times this will get you this back, and it does. Yeah, I don't go out term by term because that's what I started with at the very beginning. This times what gives me the second group? Minus 2. That's it. This factored by grouping is x minus 6 times 3x squared minus 2. That's it. And that right there is the whole process of factoring by grouping. Just group the first two and second two terms separately, factor the GCF out of each one, then factor that common factor out of the whole thing to get your factored polynomial. So the best way to do this is to practice it. So here's the first group, here's the second group. The GCF in the first group, and the GCF in the second group. So what's the GCF in the first group? Well, what's the highest factor between 10 and 6? So, you know, you could use your calculator, but it's going to be what? It's going to be 2, right? 2 goes into 6 3 times, 2 goes into 10 5 times. So 2. And what's the highest power of x cubed and x squared? That's going to be x squared. Now, let's go to the second group. So 5 and 3, do they have a common factor? No, they don't. X and a number. Uh-oh, they don't have a common factor of here either. So what's the GCF here? It's going to be 1. Now the sign here, the leading sign here is positive, so it's going to be positive 1. So the GCF here is 1. That's okay. I know I said in the first section that if you had a GCF of 1, then there's nothing to factor out. But you'll see how it factors out here. So I'm going to factor the 2x squared out of the first group, and then I have a 1 here, so I'm going to have plus 1 times the second group. Now I don't have to write that 1 here, but you'll see what I mean. So when I factor this out of 10x cubed, what's left over? Well, 2 out of 10 is 5, and x squared out of x cubed is x. 2 out of minus 6 is minus 3, and x squared out of x squared is 1. So I have 5x minus 3 now. Now if I factor 1 out of 5x minus 3, well, what do I have? I had the same thing, 5x minus 3. If I factor 1 out of that, I'm going to get itself back, right? 1 factored out of 5x is 5x. 1 factored out of negative 3 is still negative 3. So now you can see it here, right? If I look at the whole thing again, there's a common factor of 5x minus 3. So finally, when I factor the 5x minus 3, when I factor this out of the first group, what's missing? The 2x squared. Right? This times this will get me this back. This times what will get me this back? Well, this times 5x minus 3 is going to be the 1, right? This times 1 is going to give me this, right? So that's the plus 1 right there. And there it is. Pretty, pretty basic. That's factored by grouping, right? If you have a 4-term polynomial, group the first two and second two together. What's the GCF in the first group? What's the GCF in the second group? So 3 and 7, they don't have a common factor. A and A, they have a common factor of A. X and Y, so they don't have a factor of X or Y in common, so the GCF here is just A. Okay. What about the second group? Now this is a negative here, so it's going to have a negative. 3 and 7, again, no common factor. B squared, so they have a B squared in common. X and Y, this one doesn't have a Y, this one doesn't have an X, so nothing there. So the GCF in the second group is negative B squared. Alright. Factor the A out of the first group. Factor the negative B squared out of the second group. What do I have left over? So when I factor A out of 3AX, what's missing? The 3 and the X. When I factor A out of this, what's missing? The 7 and the Y. Right? Okay. When I factor this out of this one, what do I have what's missing? So a negative times a positive is going to give me negative, so this will be positive. So I have a minus, so I have a 3 and an X missing, right? Again, to check yourself, just multiply, just distribute this, see if you get back what you had, and you do. Negative B squared times 3X is minus 3B squared X. Negative times a positive is a negative. So what's missing? Negative 7Y. Ooh, so that should be no, that's right. Sorry. That's 7Y, right? Because a negative times a positive is a negative. So 7Y is missing. Yep, that's right. And if you look here, right? If I look at the whole thing now, they have a 3x plus y and a 3x plus y in common. So the GCF now is the binomial 3x plus y. I didn't write that here. I'll do it again. Sorry about that. So the GCF here was the binomial 5x minus 3. But yeah. So now when I factor that out of the whole thing, so 3x plus 7y out of the whole thing. So when I factor this out of here, what's the missing term? A. Right? Now when I factor this out of here, what's the missing term? The minus b squared. And that's it. And if you FOIL this out, like we learned when we did multiplication of binomials, how you multiply a binomial times a binomial, which is what this is. When you multiply a binomial and a binomial, you use FOIL, right? So if you multiply this out and then combine like terms, you should get back what you started with. But as you already know, factoring is just the opposite direction. So yeah, that's factored by grouping. Again, just to summarize, if you have a 4-term polynomial, consider grouping. Just consider grouping. Okay, so what we're going to do now is we're going to look at another very important technique. And this technique actually has 2 different ways. And this is very important. I can't stress that enough. So we're going to look at factoring trinomials. Remember, a trinomial is a 3-term polynomial. This has 3 terms. But it's a specific trinomial. It takes this form. It's a trinomial with a degree of 2. So this is actually a typo. I should say second degree. Sorry about that. So second degree trinomials, that's because of the second power. So second degree trinomials of this form, ax squared plus bx plus c, they are called quadratics. And that's important because factoring quadratics and solving quadratics are important things in algebra. So, quadratics take this form. Get used to this form. Understand that form. Become familiar with that form. It's a 3-term, second-degree trinomial. And it's called a quadratic. I can make a trinomial. I could write 3 terms, but they have to take this specific form to be called a quadratic. So, we can factor quadratics 2 ways. So, here's one way. We could use the AC method of trial and error. And just to peek ahead a little bit right here, we can use the AC method by grouping, which we've already looked at. And I'll show you that when we get there, but when you're factoring quadratics, you could do the AC method. Basically, you could use the AC method 2 ways. Trial and error, or by grouping. Either one is going to work just fine, but depending on the quadratic you're trying to factor, one method might be more efficient than the other. But when it comes down to it, it doesn't matter which one you use, but I'm going to show you both anyway. And I'll summarize when we look at these. So I'm going to show the trial and error way first. I'm going to do that one first. And basically, and this is literally the name of the method, it's called trial and error. And the reason it's called trial and error is because what we're doing is we're literally listing all the possible factors of a given quadratic. So why is it called the AC method? Well, it has to deal with these values right here. It has to deal with the leading coefficient A and the constant C in the quadratic. So these numbers in the quadratic give us the possible factors that will give us B. And that's what the AC method is. Just to summarize the AC method, all factors of A times C, so I take the leading coefficient A, multiplied by C, that's why it's called the AC method. So it's all the factors of AC that will give the coefficient B. And that right there is the description of the AC method. All the factors of AC that will give the coefficient B. So what we really do is we just look at the values of A and C, and we look at all the possibilities, and we find the one possibility that gives us B. If we can find that, then we factored the quadratic successfully. If it doesn't exist, then the quadratic is prime, which means it doesn't factor. Okay. So let's look at trial and error. I prefer trial and error myself, but again, it doesn't matter which one you use. Typically, the more the more sophisticated the quadratic gets, instead of listing all the possibilities, which could get a little long, you might want to consider the grouping strategy, but it doesn't matter each way. So I'll factor the following completely. Alright, so let's look at the first. So I have 5 of them here. So if you notice, these are all quadratics. AX squared plus BX plus C. AX squared plus BX plus C. AX squared plus BX plus C. Yes, sometimes they have 2 positives, a negative and a positive, or both 2 negatives. The fact is that they take a form AX squared plus BX plus C. That plus could be a minus as well, that's fine. Because plus a negative is still a plus. It's just you're adding a negative as opposed to just subtracting. It's still the same thing. Okay. I'm getting ahead of myself. Anyway, so what's the leading coefficient here? In other words, what's the value of A here? It's 1. Even though we don't see it, it's there. And what's the value of C here? It's 12. So A here is 1. And C here is 12. So what I want to do here is I want to look at all the possible factors of A times C that are going to give me 7. So what are the factors of 1? Well, that's easy. 1 times 1. Duh. In other words, since that's the case, I don't have to worry about it because I don't have to factor 1. My leading coefficient is 1. It's really easy. What are the factors of 12? Well, 1 times 12, 2 times 6, and 3 times 4. Alright, so what I'm going to have is I'm going to have a single pair for these two possibilities. So I'm going to have, so this is the leading coefficient for X, and this is going to be the value C. So this pair right here is going to give me two possibilities. Alright? So since this is the leading coefficient for X, it's going to be X and X, X and X in both possibilities. Because the leading coefficient here is 1, so it's going to be 1 times 1 times 1 times 1. That's fine. Now, I'm just looking at this first pair here. So this is going to be 1 and 12, or 12 and 1. That doesn't matter. Here's the next pair. So X, 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 right? Because it's 1 and 1. And that's just the fact that 1, 1, 1, 1. 2 and 6, 6 and 2. And then the last pair, which I will write, and I'll bring it over here. So the last pair is going to be two more possibilities. So that's going to be X, 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 and X, because 1 and 1, and if I flip 1 and 1, I'm still going to get 1 and 1, right? Obviously. And then 3 and 4, or 4 and 3. Now, all I really have, this might seem a little redundant, and actually it is. I really didn't have to write the extra case of each one, because as you'll see, it doesn't really, it doesn't really matter when the leading coefficient is 1, but it's just a good way to list all the possibilities. Alright, so what I want to do here is I want to find which outside-inside multiple is going to give me 7. That's what I want to figure out here. So remember, when you're using, this is a quadratic, right? So when we factor a quadratic, or when we distribute a quadratic, we use FOIL, right? The first and the last terms are what we looked at here. Now I want to work on the outside and inside part of the FOIL processing. I want to look at the outside and the inside part. Whichever outside and inside combine to give me 7 will be the correct factors of this polynomial, or this quadratic. So if I look at this first one, right, I'll just jot this down here. So x times 12, that's 12x. That's the outside. The inside is going to be 1 times x, which is x. Am I going to get 7x from that combination? No. No, I'm not going to. I won't get 7x. I could get 13x, right? If I add them together, I'll get 13x, but I don't have 13x, I have 7x. So this one, this first possibility is not going to work. And it's very likely that this one isn't going to work either, so we could get rid of that one as well. Because if I did it, I'm going to have x and 12x as opposed to 12x and x. So, all right, let's go on in the next case. So this outside inside, that's going to be 6x and 2x. If I add them together, what do I get? I get 8x. That's not what I have. Wah, wah. So those two don't work. Let's look here. So this one looks promising, right? Because the outside inside here, that's going to be 4x and 3x. If I add them together, I get 7x. So in order to get 7x, which is positive here, both of these need to be positive. So that means this one's positive and this one's positive. Now, like I said, you could have picked this one as well. Like if I chose this pair instead, it's still the same factors. They're just written in, they're just written in different order. For 4 times 5 is the same thing as 5 times 4. So the correct factors of this quadratic are x plus 3 and x plus 4. And you could either pick this one or this one because they're like I said, the same thing. So this factors to x plus 3, x plus 4. So yeah, I won't go through that whole outside inside process for all of them. I just want you to visually see it initially. All right. So now, what I'm going to do is I'm going to look at the next few. So again, the leading coefficient here is 1. All right, so that's just going to be 1 times 1. Now, 6 here, so the factors of 6 are 1 and 6 and 2 and 3. So let's list all the possibilities. So again, I could write, there's my first pair, and then there's my second pair. Now, since the leading coefficient here is 1, I don't have to write the same pair twice. I don't have to do that. So I just have one case of each one. And then the second one. So I have a 1 and 1, so that means they're x in both cases. Now I could write this as 1 and 6 or 6 and 1, it doesn't matter. And I could write this as 2 or 3 or 3 or 2, it doesn't matter. Again, it doesn't matter here. It didn't matter here as well. I just listed it out initially because the leading coefficient here is 1. But as you'll see, I'll get to them when we get to them. But so now I just have to pick the right one that's going to give me -5. Alright, well, if I look here, both of them could give me -5. Right? This one, so if I do outside, inside here, x times 6, that's 6x. 1 times x is x. I need to get -5 x. Right? So how do I get -5x from this arrangement? Well, if I want to get -5x here, this one should be negative and this one should be positive, right? So if I did that here, alright, so if this is -x, 6x, the negative should be here. And if this is positive x, then the positive should be here. Is that going to work though? So if I go through the FOIL process, that's x squared, that's -6x, that's positive x, which gives me -5x. Alright, that works. But when I do the last part in the FOIL process, what's 1 times -6? 1 times -6 is -6. What do I have? Positive 6. So this one is not going to work. That one's no good. So let's try this one. Alright, x times x is x squared. Outside, inside, that's 3x. Inside is 2x. How do I get negative 5x from that? If I add these together, they should both be negative, right? When I add a negative and a negative, I get a negative, right? So that means both of them should be negative. Now, if I do the last part in the FOIL process, negative 2 times negative 3 is what? Positive 6. I do have that. So this combination works. So that looks good. So my factors are x minus 2 and x minus 3. So again, trial and error is just listing all the possibilities. When your leading coefficient is 1, like it was here and here, I don't have to write a pair for each case. I could just write 1. I did it here because I was being a little redundant deliberately, but here I didn't do it here. Now, if you look at these few cases, the next few what's my leading coefficient here? My leading coefficient here is not 1, it's 3. So when I factor this, I'm going to have to write 2 pairs for each case. Alright, let's start off from the beginning. So what are the factors of 3? 1 times 3, right? Now, what are the factors of 10? 1 times 10 and 2 times 5. So now, since my leading coefficient isn't 1, it's 3, I have to write 2 cases for each pair. So I'm going to have 2 cases for the first pair, 1, 2, and I'm going to have 2 cases for the second pair, 1, 2. Alright, so what are the coefficients of the first term? So this is going to be x and 3x. X, 3x, x, 3x. Now, because I had a 3 here, I have to flip the 1 and the 10 in both cases. So my first case could be 1 and 10, and then the other one will be 10 and 1. Alright, now go to the next pair. So x, 3x, two and 5, and 5 and 2. Alright, these are all my possibilities. These are all the possibilities. These are all the possible factors for this quadratic. Now I just need to figure out which pair is going to give me 11x. Once I find that, I'll have my factors. So it's just, you know, and as you get better doing this, you won't have to write all this, the outside inside jargon down. It could just, you know, you could do that in your head almost. So this is going to be 10x. This is 3x. What am I going to get from that? Well, I'm going to get 13x. I have 11x. So this one doesn't look good. What about this one? Outside, inside. So x times 1 is x. 10 times 3x is 30x. There's no way I'm getting 11x from that, so that one doesn't look good either. Alright. What about this one? So that's 5x, right? And that's 6x. Oh, that looks promising. Can I get 11x there? Sure. In order for this to add up to 11, right? Because I have a positive 11x here, these both need to be what? They both need to be positive. Positive there, positive there. Now the only thing I have to check at this point is if the last term works out. So does 2 times 5 give me 10? It does. So this one, that looks good. And again, if you FOIL this out, you should get back what you started. So that looks good. So my factors are x plus 2 and 3x plus 5. If I did it here, I would get, well, so that would be 2, that would be 15, that would give me 17x, which is no good, so obviously that one doesn't work. So those didn't work, this one did. That's it. Alright. Again, since this is 2, I'm going to have to do pairs again. So my factors of 1 and 2 are just 1 and 2. And my factors of 15 are 1 and 15, and 3 and 5. Alright, so list all the pairs for each case. I'll put a little line here to separate this. So, the pairs for this, first pair, second pair, and then the pairs for that one. First pair, second pair. Alright, so since I have a factor of 2 here, right? So 1 times 2, this is going to be x and 2x. X, 2x, x, 2x. And I could do that for the next pair as well. I might as well, right? Now, the first pair, so I have 1 and 15, or I have 15 and 1. And then the next pair, I have 3 and 5, or 5 and 3. So now I just got to check which outside-inside combination gives me. So what's the B value here? It's -1, right? So once I figure that out, I'll have my factors. So the outside-inside here, that's 15x. That's 2x. Am I going to get 1 from that? Heck no. What about this one? So that's going to be x, and that's going to be 30x. I'm not, well, I could get 1 from that. Right? I could get 1 from that. Alright, could I get -1x from here? So how would I get -x there? Well, if I add them together, I'm going to get 31 or 29, so I don't know if that's going to work. So I guess that's not going to work. Alright, let's go to this one. So outside, inside. So 5x, 6x. Can I get -x from that? I could. If this one's negative and this one's positive, right? If I add them together, I'm going to get -x. Right? So if this is, because if you do the math on it, 5 minus 6 is -1, right? So in order for that to work, the 5x must be positive. So the outside must be positive, and the -6x must be negative. Now the only thing I have to check here is if the outside works. Does -3 times 5 give me -15? It does. Aha, ha. So that combination looks good. So my factors there are x minus 3 and 2x plus 5. Oops, sorry about that. That looks better. So those are my factors there. Yeah, so, you know, let's try the last one. I'm kind of running out of little space here, but I'll squeeze it in as best as I can. So the factors of 5 are 1 and 5. The factors of 4 are 1 and 4. And 2 and 2. Okay, so here's a pair. Here's another pair. Now again, since the leading coefficient here is a number other than 1, I have to list the pairs out. So here's one pair and another pair. And then for here, I'll squeeze this one over here. So the pairs for this combination are going to be right here. So I have x and 5x, right? So x, 5x, and all 4 of them. Alright, the first pair is going to be 1 and 4, or 4 and 1. The next pair is going to be 2 and 2. Now look at this. Oh, look at this. So, see how I, like, 1 and 4 was 1 and 4, and then 4 and 1, I swapped them around, right? Well, if I swapped 2 and 2 around, what am I going to get? I'm going to get 2 and 2. So, actually, I end up getting a duplicate. So, because of that duplicate, this is a duplicate pair. So, because of that, I could just get rid of one of them. I don't have to count for them twice. That happens from time to time. But if you go through the process, you'll see that. Alright. Now I just got to see which combination gives me negative 21. So, I know this is a little tight here, but just bear with me. So, x times 4, that's 4x. 1 times 5 is 5x. Am I going to get 21 from that? No. Doesn't look good. The outside here is going to be x. The inside there is 20. Am I going to get 21 from that? I could, yeah. How do I get negative 21x from that? Well, they would both have to be negative, right? So, I know that's really tight in there. Let me see if I can rewrite that. Sorry about that. I goofed again. That should be a 4. And that should be a 1. There we go. And that's 5x. Okay, so x, 5x, 1, 4, x, 5x, 4, 1. Okay, so the outside here is x. 4 times 5 is 20. If they add together give me negative 21, they would both have to be negative. Negative, negative. Okay. Now the only thing I have to see is if the last 2 terms multiply to give me this number. So negative 4 times negative 1 is positive 4. Ha! So that works. So I don't have to check this one. So my factors are indeed x minus 4 and 5x minus 1. And again, if you FOIL this out, you should get back this. So that's factoring quadratics using trial and error. If you have a leading if I want to summarize this, if your leading coefficient is 1, it's very easy. I mean, I think it's easy regardless, but if your leading coefficient is 1, you're going to have only one factor of each case. If your leading coefficient isn't 1, like 3, 4, or whatever, you're going to have multiple factors. You're going to have a pair for each case. So you're going to have to flip the pairs. But regardless of what your pairs are, how many pairs you have, you just got to play around with the combination until you get the middle term. And once you find it, you have your factors. Yeah, so that's the trial and error method. What I'm going to look at now is I'm going to look at the grouping method. So how do we factor quadratics using the AC method for grouping? Well, so again, I say this here. If the leading coefficient is not equal to 1, then perhaps you should try this. But it's really up to you. If you like doing it this way or the other way, I prefer the trial and error way because I understand it. And I've been doing it for nearly 20 years. So I rarely do it this way unless the factors could get a little crazy. So I'm going to show you how to do it. So what's the value of A here? So this is AC by grouping, is what I'm going to do here. So the value of A here is 2, and the value of C here is -5. So since this is AC, I'm going to multiply them together. So what's A times C? 2 times -5 is -10. Alright. So what I want to do is I want to find the factors of -10 that give me +9. So let's list the factors of -10. So that could either be 1 and -10 or -1 and 10. Right? It could also be -2 and 5 or 5 and -2. So if I look at this right here, which one of these cases is going to give me the +9 here? What I want to do is, when I'm using the AC method by grouping, which of these pairs, so I have this pair, this pair, this pair, and that pair. When I add these pairs together, which one's going to give me +9? Well, it's going to be this right here, right? It's going to be this pair. If I add them together, right, If I add them together, what's -1 plus 10? It's 9. What do I have here? 9. So this is the pair I want. So what I'm going to do is I'm going to express this middle term. So let me rewrite the quadratic over here. What I'm going to do is I'm going to express this middle term. I'm going to express that as a sum of these two factors here that gave me 9. So instead I'm going to write this middle term as -x plus 10x because that gave me 9x. These values right here represent the values of the b term. So I'm just going to replace the 9x like this instead. So let's write that. So I'm going to have 2x squared, and now like I said, instead of writing 9x, I'm going to write -x plus 10x. And then I had a -5. So now what I have here is I have a 4-term polynomial. 1, 2, 3, 4. Basically, this just became this right here. By doing that, by using the AC method and finding which ones give me the middle term, I could just rewrite the middle term as the combination that gives me that term, which is what I did. So now I have a 4-term polynomial. How do you factor a 4-term polynomial? You use grouping. Ta-da! So now from here, you're just going to factor this by grouping, which we already know how to do. So what's the GCF of that group? What's the GCF of that group? So the GCF of this group is what? Well, they don't have a 2 in common, but they have an x in common. What's the GCF here? Now this is positive, so this won't be positive. They have a factor of 2 in common, right? 2 goes into 10. Oh, I'm sorry, not 2. 5. My bad. They have a factor of 5 in common. So now, when I factor this, I factor the x out of the first group, and I factor the 5, which is positive, out of the second group. Right? So when I factor x out of the first group, what do I have left? Well, x out of 2x squared is 2x, and x out of minus x is minus 1. When I factor a 5 out of 10x, what do I have? I have a 2x. When I factor a 5 out of negative 5, I have a negative 1. Right? 5 times negative 1 is negative 5. Hey, look at this. If I look at the whole thing now, 2x minus 1, they have a GCF of 2x minus 1 now, which I could factor out of the whole thing. So when it's all said and done, right, if I factor the 2x minus 1 out of the whole first group, what's missing? Just the x, right? This times this gives me the first group, and then this times what gives me this one? What's missing? The plus 5. And that's it. So if I wanted to do it this way by using the AC method with grouping, I can. You're just rewriting the middle term as the AC factors that give you the middle term, and then use factor by grouping. And those are the factors. Again, you know, it's pretty, either one is going to work. So if you did the trial and error method here, you know, you're still going to get this. You're just going to do it a different way. If you list all the possibilities, eventually you'll get to this possibility. All right. So let's look at this one here. So A here is 3, and C here is 8. So the factors of, so what's going to be A times C here? 3 times, oops, focus is going out. So 3 times 8 is 24. Alright. So what are my factors of 24? Well, I have 1 and 24. Right. I have 2 and 12. I have, what? Does 3 go into 24? Yes, it does. 8 times. Does 4 go into 24? Yes, it does. 6 times. And I think that's it. So those are all my factors of 24. Now, which one of these, when I add them together, are going to give me 14? Right here, the 2 and the 12. So that should be pretty obvious, right? 2 plus 12 is 14. So what I have is 2x plus 12x is 14x. So I could rewrite this term as 2x plus 12x. Like what I did up here, I rewrote the 9x as negative x plus 10x. So now I could rewrite this. So I have the 3x squared out front. I have the plus 8 at the end. So instead of writing 14x, I could write 2x plus 12x. Now, a question I get from students, and this is a good question. A question I get from students is, does it matter if I rewrite, what if I wrote this as 10x minus x instead of this? And the answer is it doesn't matter. You will get this at the end. Provided you factor it correctly, you'll get the same result. So I could have written this as 12x plus 2x instead of 2x plus 12x. I could have written this in reverse order. I'm still going to get the same thing. So factor that group. I now have a 4-term polynomial, which you could use by grouping. So the GCF in each group. So what's the GCF here? Well, 3x squared plus 2x. So they have an x in common. What do they have in common? 12 and 8. So that's going to be what? 4. Alright, so I factor an x out of the first group, I factor a 4 out of the second group. What's missing? Well, it's x out of 3x squared is 3x. X out of 2x is plus 2. 4 out of 12x is 3x. 4 out of 8 is 2. Ah, there it is. They have a common factor. They have a GCF of 3x plus 2. So now when I factor that, so when I factor 3x plus 2 out of the first group, what's missing? The x. And when I factor the 3x plus 2 out of the second group, what's missing? The 4. Ta-da! So, yeah, it doesn't matter which way you do it, just as long as you're consistent. I personally prefer the the trial and error way, but that's just me. Some people prefer it this way. Okay, let's look at the last one here, and then we're going to go on to the last page. So again, A here is 2, C there is negative 25. So A times C is what? 2 times negative 25 is negative 50. So what are the factors of negative 50? Well, I have 1 and negative 50, or negative 1 and positive 50. Does 2 go into 50? Yes, it does. So I have 2, negative 25, or I have negative 2 and 25. So these are all possibilities. What else goes into 50? Does 3 go into 50? No. So you could use your calculator here when numbers get big. That's fine. 3 doesn't go into 50. Does 4 go into 50? Nope. 5 goes into 50. How many times? 10. So I have negative 5 and 10, right? Or I have 5 and negative 10. And what else? I don't think anything else goes into 50. 50 divided by 6. No. I think that's it. 50 divided by 7. No. Nope, that's it. Alright, so those are all my possibilities for negative 50. Now, which one of these, when I add them together, so I have 1, 2, 3, 4, 5, 6. So I have 6 different possibilities. I need to get negative 5x, right? So which one of these, when I add together, is going to give me negative 5? It looks like the last one, right? Right, if I add 5 minus 10 is what? Negative 5. What do I need? Negative 5. So this one looks like I should be 5x minus 10x to give me negative 5x. So I'm going to rewrite the middle term as 5x minus 10x. Alright. 2x squared. Now I'm going to rewrite the middle term. Alright. I'm going to rewrite the middle term as 5x. So this is positive, right? So that's plus 5x minus 10x. And now minus 25. So now I have a 4-term polynomial, right? So this middle part right here is just an expression for negative 5x, which I got from the AC combination. You know, once you understand the process, it's pretty easy, I think. So now I could just do the grouping, right? So what's the GCF in the first group? So the GCF here is going to be what? X. So I'll factor that out of the first group instead of writing it out. What's the GCF in the second group? So now in the second group here is negative, right? So it's going to have a negative with it. So what's the highest number that goes into 10 and 25? I think that's going to be 5, right? So negative 5. Right. So when I factor an x out of 2x squared, I have 2x. When I factor an x out of 5x, I have 5. Negative 5 out of negative 10, what's missing? That's going to be a 2x, right? Yep. Negative 5 times 2x is negative 10x. Negative 5 times what gives me negative 25? Oh, it's going to be positive 5. You can see it now, right? Here's the 2x plus 5, here's the 2x plus 5. So I can factor that out of the whole thing. See, notice how, you know, when you do it enough times, you don't have to write all the details out because you start to understand it. When you factor that out of this group, what's missing? The x. When you factor this out of this group, what's missing? The minus 5. And that's how you factor using the AC method by grouping. Again, it depends on what you have, but if you want to use trial and error, which in my opinion looks worse than it really is, or if you prefer using grouping, I think trial and error is quicker. It's fewer steps, and you'll appreciate the trial and error method when you do more complicated algebraic operations. But that's just my opinion. But yeah. Alright, so the last page of notes is kind of like a summary of these techniques that we've looked at so far. So again, I stressed this in the previous section, but it's always a good idea to see if a GCF exists before doing anything else. And you know, often when you're factoring a polynomial, you know, you might have to factor it several times. You know, factoring it once is usually uncommon. You have to factor it as much as you can. So the first thing you should do, and we'll summarize this after we look at all the techniques of factoring, is you want to factor out a GCF if it exists. So is there a GCF here? Now, when I say a GCF, I mean the whole thing. We're not going to use grouping here because there's only 3 terms here. So is there a GCF between 20, 40, and 25? Yeah. So the highest number that goes into those numbers is 5, right? Again, you could do the math number, go down to GCD like I showed you in the first section. So what's the GCD between 20 and 40? 20 comma 40 is 20. But what's the GCD between 20 and 25? So the highest number that goes in all 3 is going to be 5, right? Alright, so the GCF here is 5. Anything else? Yeah, x to the 4th, x cubed, x squared. So the highest power of x they have in common is x squared. So my GCF here is 5x squared. Let's factor that out. So what do I have left over? 5 out of 20 is 4. X squared at x to the 4th is x squared. 5 out of 40 is negative 40 is negative 8. X squared out of x cubed, x. 5 out of negative 25 is minus, what, 5 times 5? X squared out of x squared is 1. So that's, when I factor out the GCF, so this is what I have left over. I have 4x squared minus 8x minus 5. Now, if you're not practiced in factoring, you might think you're done, right? But I'm not done. Why not? This right here is what? That's a quadratic. That's a quadratic. So I need to see if this factors by using the AC method. I could use trial and error or grouping, like we just did. We just did that. So just because you factor it once doesn't mean you're done. You got to see if any of the factors also factor. That happens more often than you think. Okay. How do I factor a quadratic? I could use trial and error. Or I could do grouping. Whatever floats your boat. Use the AC method, either by grouping or trial and error. I'm going to use trial and error. So I'll just put this off to the side. I won't forget it at the end. But so when I factor this, right, my factors of 4 are 1 and 4 and 2 and 2. My factors of 5 are 1 and 5. Okay, so there's one pair, there's another pair. So now, because I have two combinations for the leading term, I'm going to have an additional pair for each case. So let's list all the pairs. So my first pair, so the first here is going to be x and 4x, x, 4x, 1 and 5, 5 and 1. Okay. Now the next pair. So this is 2x, 2x, right? Because the leading coefficient here is 4. And now I have 1 and 5, and 5 and 1. Hey, guess what? Don't you see something cool here? Remember how I said duplicate cases could come up? I have 2x and 1, I have 2x and 1, 2x and 5, 2x and 5. So, as it turns out, this right here is a duplicate case. So I've counted these more than once. I don't have to worry about it. So I can get rid of one of them. So I can get rid of one of them. It doesn't matter. It's a duplicate case. Alright, so now I just got to figure out which one's going to give me, like which one of these three is going to give me -8. Alright, so the outside here, that's 5x. The inside is 4x. That's going to give me 9x. So that's no good. That one's no good. Alright. Outside. Inside. That's x. That's 20x. That's going to give me 21x. So that one's no good. What about this one? This is the only one on the left. It should work. 10x and inside is 2x. Is that going to give me 8x? Yes, it could. Yep. So I need negative 8x, right? That's what I need. How do I get that from what I have? So in order for that to work, the 10x should be negative and the 2x should be positive. So the negative 10x, so the 2x and the 5, that should be negative. And the positive 2x, that should be positive. Now the only thing I have to check here is if 1 times negative 5 gives me negative 5. It does. So this one looks A-okay, baby. So when it's all said and done, this also factors to 2x plus 1 and 2x minus 5. So this whole thing factors to be in total as 5x squared and 2x plus 1 and 2x minus 5. So those are my factors. So this factored to those two, which I did by the AC method. I did trial and error, but if you want to do the grouping, that's up to you. So yeah, the important thing to understand here is, you know, just because you factor once doesn't mean you're done. Sometimes the factors also factor. Okay. Now, this one is not like something you've seen before, but I have to explain it because it shows up. This one, so if I check to see if a GCF exists here, it doesn't, right? 3, 13, and 12. There's no number there in common. This is x squared, this is 3x, this is y squared. They don't have a variable in common either. So the GCF here is 1. And so how do I factor it? It only has 3 terms, so I can't use grouping, right? So is this, and so the only thing that's left for me to consider is factoring a quadratic. But this doesn't really look like a quadratic because this term has a variable in it, right? But as it turns out, this is a unique case. This is a quadratic in 2 variables. This is a unique case. So let me show you what I mean. So if I wrote the form of a quadratic, ax squared plus bx plus c, right? The values a, b, and c are the coefficients and the constant, right? The x variable is the quadratic part. So if I wrote this down here just to show you, 3x squared plus 13xy plus 12y squared. This is a quadratic in 2 variables. So if I look at the first term, right, the a matches up with the 3, right? If I look at the second term, I have a b and an x. Well, I have a 13xy here. So what I should do here to match this up to the quadratic form is rewrite this not as 13xy, but as 13yx. I just want you to see this. So the a here, the a variable, the a coefficient is 3. Now the b here is going to be 13y because this is ax squared plus bx plus, and the c here is going to be the whole thing. So that looks a little confusing initially, and that's okay. But this is a quadratic in 2 variables. It's a unique kind of quadratic, but it's not too bad when you have to factor it. You could so this is a quadratic, and you could factor it with the AC method. Either one will work just fine. I'm going to use trial and error. So again, what are the coefficient? The coefficient of A here is 3. What are the factors of 3? 1 and 3. Now, because my C here isn't just a number, it's a number and a variable, I'm going to include the whole thing. What are the factors of 12y squared? So, in order to do that, just look at the number first, and then I could just make each one with a y in it. So, what are the factors of 12? 1, 12, 2 and 6, 3 and 4. Now, because this contains a y squared, they both need to have a y, because a y times a y will give me a y squared. So this is 1y and 12y, 2y, 6y, 3y, 4y. So I have 1, 2, 3 pairs. So I have 6 total factors to consider here. Okay. So the first pair, I'm just going to go down the side here. The second pair, and then the third pair. All right. So I have a 1 and a 3 here, so that's going to be x and 3x for the 3x squared. X, 3x, and that's the case in all 6 of them. Y, 12y, 12y, and y. So you just flip them. Next case, 2y, 6y, 6y, 2y, 3y, 4y, 4y, 3y. So now I just got to check which ones are going to give me 13xy or yx. Same thing. xy, yx is the same thing. So I do that by the outside inside, right? Okay, so outside, that's 12xy. Right, this is 12xy, 3xy. Is that going to give me 13xy? No. So this one, no. This is 1xy. 12 times 3 is 36. Is that going to give me 13? Hell no. 6xy. 6xy. Is that going to give me 13? That's going to give me 12. No. Alright. That's 2xy. 6 times, that's going to be 18xy. That would give me 20xy. I need 13. That one's no good. Alright. This is 4xy. That's 9xy. What's 4 plus 9? 13xy. This looks good. This looks good, right? 4xy and 9xy give me 13xy, which is what I need. And since these are both positive, right, both of these are going to be, right, so, you know, if I do the outside-inside part again, that's 4xy, 3y times 3x is 9xy. They both add up to be 13xy. So for that to work, which is what I have, they both need to be positive. Those are my factors. So when it's all said and done, this thing factors to be 3 plus x plus 3y, and 3x plus 4y. It's okay if you don't understand this one right off the bat, but if you do, then you should be good with factoring quadratics. This is just a quadratic in 2 variables, but you should definitely keep an eye out for this in your homework. So the last one right here, I'll go through this one really quickly. Again, first thing you should do is see if there's a GCF. And there is a GCF, it's 4. Right? 4 goes into 16 and 48. and the highest power of x is squared. 4x squared out of there is going to be an x squared. 4x squared out of here is going to be, so that's going to be plus 4x, right? 4 out of 48 is what? X squared out of x squared is 1. Now again, what do I have here? This is a quadratic. Which you need to factor with the AC method. Now this is an easy quadratic because the leading coefficient here is 1. So this one's easy. So to factor this, coefficient here is 1. The factors of that are 1 and 1. And the factors of 12, 1 and 12, 2 and 6, 3 and 4. Now because the coefficient here is 1, I don't have to write pairs. I could just consider 1 for each case. So I have 1, 2, 3 cases. 1, 2, 3. So this is going to be 1, 2, 3. Because the leading coefficient here is 1, I don't have to do that. I don't have to flip them. So this is going to be, so the leading coefficient here is x, 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 x. 1 and 12, 2 and 6, 3 and 4. All right. So, what are our factors here? So which one of these is going to work? So the outside here is 12 and the inside here is 1. Is that going to give me, I need 4, right? I need 4x. So 12 and 1, it's going to be 13. Nope, that's not going to work. That's no good. That's 6x, that's 2x. That's going to give me 8x. I need 4x. That one's no good. 4x and 3x, that's 7x. I need 4x. That one's no good. Oh no! I've exhausted all the possibilities. So what's wrong here? Well, guess what? This quadratic doesn't factor. It's prime. So this doesn't factor. So the only thing I can factor out of this is the GCF 4x squared. So the only thing I could factor is that, and that's it. This is a quadratic, but it's a prime quadratic. So, but you still have to check to see if it factors. So since they all don't work, that's it. So yeah, that was a long section, but an important section. Learning how to factor quadratics is very important because it's something you're going to do a lot in future math courses if you have to take them. So again, to summarize this section, factor by grouping and factoring quadratics. Grouping if you have 4 terms. Quadratics, use the AC method. You can use the AC method 2 ways. List all the possibilities, that's trial and error, or use factor by grouping. And to summarize, you should always factor a GCF out first before doing anything else, if you can. And in the next section, we're going to look at 2 more methods of factoring, which are specific cases as well. Factoring what they're called differences of sums and cubes and whatnot. And then that'll be it. And then we're just going to look at a summary of all the factoring techniques we've looked at. So, yeah. So yeah, this was a long video, a long section here, but all right, that's the end of the video.